So in this lesson, it's the second part of 3.5, and we're still dealing with slope-intercept form, which was y equals mx plus b. So I'm just going to go right to let me just refresh your memory a minute. The m in the y equals mx plus b was slope. So if you had an equation that looked like this, you would know that your slope of that line would be 2. So rise over run is 2. We identified the b as the y-intercept, but we never really covered exactly what it meant. Y-intercept, or b, in your slope-intercept equation is where the line crosses, the point where the line crosses the y-axis. So let's look at that on a graph. Let's look at y equals 2x plus 3 on a graph. So in the equation y equals 2x plus 3, I know that the slope is 2, and I know that the y-intercept is 3. And it was a positive 3. So I know just from that equation that at positive 3, it crosses the y-axis. Now, as long as I know that and the slope, I can graph this line because the rise over run is 2. Well, if the slope equals 2, that is the exact same as 2 over 1. And there's your rise over run, both positive directions. So you go up 2 over 1, and that's your next point. And you can graph that line just using that information, the slope and the y-intercept. Excuse me. So while we're talking about y-intercept, let's look at a different kind of a line. One, for instance, that looks like this orange line. So the orange line would have an equation of x equals something because it crosses the x-axis, correct? X equals -6. So x equals -6 is the equation of the orange line because it crosses the x-axis at -6. If you notice, this line is a vertical line, and I hope you remember that it has an undefined slope because it's straight up and down, and it has no y-intercept. Why does the straight up and down line have no y-intercept? And I hope you guessed because it never crosses the y-axis, and you would be correct. If a line never crosses the y-axis, it has no y-intercept. Therefore, the equation, x equals -6, never really fits into our slope-intercept form because there is no y-intercept. That being said, it does have an x-intercept because it does cross the x-axis. So the x-intercept is -6, which is seen in the equation. Okay, so let's move on to number 1, and I want to recreate the picture that you see in number 1. And as I'm drawing that, I see that at -4, -1, there's an exact point. And I know that it crosses at -2. And so from that, I'm going to go ahead and sketch this line in, and hopefully it'll look like the one on the activity. Just like so. Here's my x and my y, and of course the x and the y-axis goes to infinity, so it has arrowheads as well. Now, what I need to do is pick out the equation of this line just from that picture. And I need to put it in slope-intercept form. Well, I see immediately that my y-intercept is -2. So therefore, I know my equation has a -2 on the end. What I don't know yet is the slope. Well, I hope you recall that slope is rise over run. And if you don't recall that, you can always use the equation y2 minus y1 over x2 minus x1 to figure out the slope, because you have two exact points on this line. So you have a point number 1 and a point number 2. So you could use the equation to find slope and those 2 points. However, because I have such a small distance to go, it would be a lot easier to say I go down 1, so my rise is -1, and I go over 1, 2, 3, 4, positive 4, and so my slope is -1 over 4. And if you look at the answer choices, D is going to be the answer. Y equals -1 over 4x minus 2. And so for the first few problems, that's all you're going to do. And remember, if you have an equation that looks like this one, that is still in y equals mx plus b form. Slope is 1/2, because it's always the coefficient of your x, and the b would have to be 0, because it would have simplified and gone away. Now, toward the end of 3-5 Part 2, for instance, number 21, it's a different story. You're not given a graph. So remember, way back when we started linear equations, if you had an equation, and I just made this up, it's not found anywhere, I don't think, and you wanted to graph that before you knew anything about slope, you would plot points. So if x equaled -1, you'd plug that in. So y would equal 3 times -1 plus 2, which would be -3 plus 2, which is -1. And then if you pretend x is 0, that would give you 2. And if x was 1, you just put those x values in place of x in your equation, and you figured y. And that gave you some points on your line. And you made your dots, and you connected them and all that stuff. Well, what you may not realize is there's a relationship between that particular x and that particular y. Anytime y is -1, x is also -1. Those are points on your graph that lie on this line. The equation is no more than the name of a line. So if you take those points, and let's just say we're going to use the first point, -1, -1, and you were to put them in an equation. So y is -1, and x is -1. This should be a true statement. It should indeed equal one another. So does -1 equal -3 plus 2? Does -1 equal -1? And yes, it does. So the relationship is always the same when given points. And you might be asked a question such as, hey, does the point 4, 7 lie on that line? And to test that, you would plug in your y and your x, and you would check to see if you have a true equality. So let 7 go in place of y. And right now we're asking ourselves, is this equal? Let 4 go in place of x. Now do some simplifying. 12 plus 2. So does 7 equal 14? Well, no, it doesn't. And since it doesn't, that point is not on the line y equals 3x plus 2. However, we do know that this point is on the line because it gave us a true equality. So you can use this information to check points, to see if they are a solution to an equation, or to see if they lie on the line. But you can also use this relationship in a different way. So for instance, number 21, you're given 2 points, and you're trying to find the equation of a line. Well, from those 2 points, you could definitely find your slope. So m equals y2 minus y1 over x2 minus x1. And we're going to assign a number. So I'm just going to make this be point number 1 and that be point number 2. Therefore, my y2 is 2. You have to put the minus sign. My y1 is 3. My x2 is 5. You have to put that minus sign. This is part of the formula, so you always write it. My x1 is 4. Well, 2 minus 3 is negative 1, and 5 minus 4 is 1. And that simplifies to negative 1. So I know that on number 21, because they've given me 2 points, that the slope is negative 1. Well, I know that my equation, mx plus b, would look something like this. What I'm missing is my b. Well, if I have an equation that just has one unknown value, I can always solve for that unknown value, right? We've been doing that. You started that in algebra. If I just only had a y and an x to plug in here, I could solve for a b. Well, they just so happen to have given you 2 different x's and y's. You can choose either one of those and solve for b. Once you have that m, you have narrowed the field down to only one unknown. Well, let's try it with both points. So again, the question has given me 2 points on this line, so I have an x and a y that will definitely make my equation true. They're definitely solutions. And so I can solve for this b. Well, let's use point number 1. So y would be 3. We already know the slope is negative 1, and x would be 4. And I don't know b, that's what I'm trying to find, so I can complete this equation. So 3 equals negative 4 plus b. Add 4 to both sides. So 7 would be b. You can stop right there and you can say, hey, my equation is y equals negative x plus 7. But I want to show you that it doesn't matter which point you choose. So let's take point number 2 and go through the same process. I have an x and a y on point number 2. So let's plug them in. Y is 2. X is 5. And I'm trying to find b. So 2 equals negative 5 plus b. Well, if you add 5 to both sides, 7 equals b. So your slope is negative 1, and your y-intercept is positive 7. Therefore, your equation looks like that. And if you wanted to write y equals negative 1x plus 7, you could. We just usually never write the coefficients of 1 in math because 1 times something doesn't really change it. And I believe that will conclude finding the equation of a line from either a graph or 2 points.